In modern JavaScript, there are two major paradigms: object-oriented programming and functional programming. And so, in this section, you're gonna learn everything you need to know about object-oriented programming in JavaScript. And this is absolutely essential if you want to become a professional JavaScript developer. So we're gonna dive really deep into what object-oriented programming actually is and different ways of implementing it in JavaScript. And we're gonna start with constructor functions, then move to ES6 classes, and also talk about object.create. And by the end of the section, we will even implement inheritance between classes using all these different techniques. So this is going to be a full-packed section, and so let's dive right in. So this section is about object-oriented programming, and this lecture is going to be a very general, high-level overview of this programming paradigm. So we're going to talk about what object-oriented programming is, how it works in general, and about its four fundamental principles. So this is going to be a really important and valuable lecture, and so let's get started. So first of all, what is object-oriented programming? Well, object-oriented programming, or OOP in short, is a programming paradigm that is based on the concept of objects. And paradigm simply means the style of the code. So the how we write and organize code. Now, we use objects to model, so to describe aspects of the real world, like a user or a to-do list item, or even more abstract features like an HTML component or some kind of data structure. Now, as we already know, objects can contain data, which we call properties, and also code, which we call methods. So we can say that by using objects, we pack all the data and the corresponding behavior all into one big block. So again, that's data and corresponding behavior. And this makes it super easy to act directly on the data. And speaking of blocks, that's exactly what objects are supposed to be. So in OOP, which is the acronym that I'm going to use instead of object-oriented programming, okay, so in OOP, objects are self-contained pieces of code or blocks of code like small applications on their own. And we then use these objects as building blocks of our applications and make objects interact with one another. Now, these interactions happen through a so-called public interface, which we also call API. This interface is basically a bunch of methods that the code outside of the objects can access and that we use to communicate with the object. Okay, so let's take a breath here, because this all sounds kind of abstract, right? But don't worry, it will make more sense once we start developing these concepts using code throughout this section. But anyway, why does OOP actually exist? Well, this paradigm was developed with the goal of organizing code, so to make it more flexible and easier to maintain. So before OOP, we might have a bunch of code scattered across multiple functions or even in the global scope without any structure. And this particular, crazy style of code is what we usually call spaghetti code. And spaghetti code makes it very hard to maintain large code bases and let alone add new functionalities to it. So the idea of OOP was basically created as a solution to this problem. And apparently it worked, because today OOP is probably the most popular and most widely used programming paradigm in large-scale software engineering. Now, OOP is certainly not the only way of writing organized and maintainable code. So in fact, there are many other paradigms that have become increasingly popular, and one of them is functional programming. And functional programming allows us to achieve the exact same goal of basically avoiding spaghetti code. And as I have been saying, we will talk about functional programming later in the course and compare it with object-oriented programming. But for now, let's focus on OOP. Now, actually, using objects is nothing new for us at this point, right? We have been using them all the time. However, up until now, we have basically only used objects as loose collections of data and without making them interact with one another. Also, we didn't have a way to generate objects programmatically. All we ever did was using simple object literals. But in OOP, we actually need a way to generate, so to create new objects from our code. And to do that, in traditional OOP, we use something called classes. You can think of a class as a blueprint, which can then be used to create new objects based on the rules described in the class. So it's just like in architecture, where the architect develops a blueprint to exactly plan and describe a house. But the blueprint is really just an abstract plan, like a set of rules, but nothing tangible that you can actually touch. However, from that blueprint, many real houses can then be built in the real world. And with classes, it's just the same. So let's take a look at this fictional user class as an example. And I say fictional because this is not actual JavaScript syntax, okay? Because JavaScript does not actually support real classes like I'm explaining here. We do have a class syntax in JavaScript too, but it still works a bit differently from what I'm going to show you here. However, the idea of creating objects from a kind of blueprint is still a very useful mental model to have, because in general terms, this is still how OOP works across all languages, and that includes JavaScript. And so that's the reason why I'm showing you this here, so as a conceptual overview and for you to have this as a mental model. But anyway, back to our fictional class here, we can see that it kind of describes a user who has a username, a password, and an email. So it's a description of data about a user, but it's not the data itself yet. Because remember, the class is really just a plan, and the plan doesn't contain the real-world data just yet. On the other hand, we then have the behavior that is associated with the data. And in this case, that's just a login method and a method to send messages. So just like we learned in the last slide, this class has everything related to a user. So data and behavior all packed into one nice self-contained block. But now let's use this class and actually create a new object from this class. And you see that now we actually have real data about the user in the object and not just a description of the data like we have in the class, so in the plan. Now we call all objects created through a class instances of that class. So again, an instance is a real object that we can use in our code, which was created from a class. And the class itself is not an object. All right? So back to the blueprint analogy from earlier, this instance is like a real house which was created from the abstract blueprint created by the architect. And the beauty of this is that now we can use this class to create as many instances as we need in our application, just like we can build multiple houses from just one blueprint, right? And all of these instances, so these objects, of course, can have different data in them, but they all share the same functionality, which is to log in and to send messages. Okay, so now we know that we can create classes to generate objects from these classes. So we know how classes work, but the next logical question is, how do we actually design a class? Or in other words, how do we actually model real-world data into classes? So these questions are just like an architecture student asking, well, how do we actually plan and design a house? And that's, of course, a very good question. Now, the answer is, as you can imagine, not straightforward. So there's not a single correct way of designing classes. There are, however, 4 fundamental principles that can guide us toward a good class implementation. And these principles are abstraction, encapsulation, inheritance, and polymorphism. And these are actually techniques that can also be used outside of OOP, but they are especially relevant in this context. So let's now take a more detailed look at each of them. And the first one is abstraction. And abstraction basically means to ignore or to hide details that don't matter. This allows us to get an overview perspective of whatever it is that we're implementing instead of messing with details that don't really matter to our implementation. So let's say that we're implementing a phone for a user to use. And even though this doesn't make much sense in code, it's still a great example and analogy. So without abstraction, we could design our class to include everything that there is about a phone, including all the internal stuff like verifying the phone's temperature and voltage, turning on the vibration motor or a speaker, and other low-level details. But as a user interacting with a phone, do we really need all of this detail? Well, I guess not, right? So in reality, when we interact with a real phone, all of these details have been abstracted away from us as the user. And all that we're left with is a simple phone that we basically only interact with using the home button, volume buttons, and the screen. Everything else is gone because we simply don't need it as a user. So the phone then operates kind of as a black box without us seeing what is happening inside. Now, of course, internally, the phone still needs to vibrate and to measure the voltage or to turn on a speaker, but we can hide these details from the user. And that is exactly what abstraction means. Now, going back to the example of a user from the last slide, we could implement a user's phone number, mailing address, hair color, shoe size, and tons of other stuff that we might not need in our application. So we simply ignore these details. Now, abstraction is really important, not just in OOP, but in programming in general. In fact, we create and use abstractions all the time. For example, take the addEventListener function that we use all the time. Do we actually know how exactly it works behind the scenes? Well, we don't. And do we care? No, not really, right? And we don't have to, because once more, the low-level details of how exactly it works has been abstracted away from us. We are simply the user, and so we can simply use that function without completely understanding it and without having to implement it ourselves. So that's abstraction, which actually blends in with the next principle, which is encapsulation. And encapsulation basically means to keep some properties and methods private inside the class, so that they're not accessible from outside the class. However, some methods can of course be exposed as a public interface, which we call API. And this is exactly what I meant at the beginning of the lecture when I said that interactions between objects happen through a public interface. And going back to our example of a user from before, this is what private properties might look like conceptually. And again, I'm talking hypothetical here, because this private keyword here actually does not exist in JavaScript. But anyway, as we already know, outside code now can't access these properties. However, inside the class, they are still accessible. For example, the password is of course necessary in the login method, right? And so there we can use it. And by having these critical properties nicely encapsulated like this, we prevent external code from accidentally manipulating this internal state. And by the way, the term state simply refers to an object's data. Okay? Anyway, this is really important because allowing external code to manipulate internal state directly can cause many kinds of bugs, especially in large code bases and developer teams. Now, as you see, there's also a private method here, the check spam method. Again, it's not accessible from outside the class, but it's used internally to check if a comment is spam or not. So we want no one else outside of the class to be able to use this method. And so basically, we don't make it part of the public interface. So the public interface is essentially all the methods that are not private, so that are not encapsulated. So making methods private makes it easier for us to change our code without breaking code from the outside, which might rely on some of these methods. For example, if the check spam method was public, then it could be used anywhere in our code. And if we then change the implementation of the method, it might break that code that is relying on it. So again, this helps avoiding bugs and also spaghetti code. And really, this is not just some theory, this is a real practical scenario. All right, so there is a real reason why encapsulation and private methods and properties exist. So in summary, we should always have the goal to nicely encapsulate most of our state and methods and only leaving essential methods public for the reasons that I just explained. Next up, we have inheritance. So let's say we have these two classes, user and admin, which stands for administrator. And as we can see, they have actually a lot in common. In fact, admin has all the properties and methods that user has, right? And that actually makes sense because if you think about it, an admin is also a user. So an admin also needs a password and an email, and he also needs to log in, for example. However, if we design our classes like this, so as two separate identities, we will end up with a lot of duplicate code. And we already know that that's bad, right? But well, that's where inheritance comes into play. So in OOP, when we have two classes that are closely related, like user and admin here, we can have one class inherit from the other. So we will have one parent class and one child class. And the child class then extends the parent class. Okay, great. But what does all of that actually mean? Well, it's actually quite intuitive, I think. So just like you as a child probably inherited some features of your parents, a child class inherits all the properties and methods from its parent class. Now, in more formal terms, inheritance makes all properties and methods of a certain class available to a child class, which, of course, then forms a hierarchy between these two classes. And the goal of this is to reuse logic that is common to both of the classes. In this case, both the admin and the user need to log in. And so instead of writing that logic twice, it makes sense to inherit the login method from the more global class, which is the parent class user, to the more specific class, which is the child class admin. Now, of course, a child class can then also have its own methods and properties. So at the end of the day, the child class ends up with some methods and properties from its parent and some of its own. So we can say that the admin is also a user, but basically an extended user, so with some added functionality. Okay, and finally, the last principle is polymorphism. And polymorphism sounds a bit weird, which is because it comes from Greek, where it literally means many shapes. Now, in the context of OOP, in simple terms, polymorphism means that a child class can override a method that it inherited from a parent class. And here are our user and admin classes again. But now we also have a third class, which is the author. Now, admin and author are both really just special kinds of users. And so it makes sense that they both inherit from the user class, just like we studied in the last slide. Therefore, they inherit all the properties and methods from the user class, but we're going to focus on the login method now. Now, let's say that an admin requires a different kind of login method. For example, a more secure one, which has two-factor authentication. And let's say that we also need a special login method for authors. So how do we give them different login methods? Well, it's actually quite simple. In each class, we simply just write a new method, which is also called login, and then, according to polymorphism, that login method will override the login method that has been inherited from the user class. And that's actually it. That's all you need to know about polymorphism. And actually, that wraps up this introduction to object-oriented programming. So I know there was a lot to take in here, so make sure to understand everything before actually moving on in this section. Now, next up, we're going to talk about how object-oriented programming actually looks like in JavaScript. Because, as I said in the beginning, it is implemented in a bit different way from what I explained here in the beginning with classes and instances. It's still crucial to understand that, but again, in the next video, we will see how JavaScript does it. Welcome back to the second part of the introduction to object-oriented programming. And in this lecture, we will learn about OOP specifically in JavaScript. So how it's different from the more traditional OOP, and also different ways of implementing this paradigm in JavaScript. And don't worry, this will be a lot shorter than the last lecture. So just to review, in the last lecture, we talked about the classical object-oriented programming model with classes and instances created from these classes. And remember, a class is like a blueprint, which is a theoretical plan, and that we use to build many houses in the real world. And in the same way, the theoretical class can be used to create actual objects, which are called instances, and which we can then use in our code. And this process of creating an instance is called instantiation. Now, earlier I said that in JavaScript, things work a bit differently. So why did I first tell you about classes and instances? Well, it's because we do have similar concepts in JavaScript, and so it's very useful to first understand the class instance model. Plus, many people also just use this terminology in the context of JavaScript. And finally, JavaScript syntax itself uses also some of these terms. For example, instances. And so you really need to know what a class is and what an instance is. Now, anyway, how does OOP actually work in JavaScript? Well, in JavaScript, we have something called prototypes. And all objects in JavaScript are linked to a certain prototype object. So we say that each object has a prototype. And now here comes the magic. So the prototype object contains methods and properties that all the objects that are linked to that prototype can access and use. And this behavior is usually called prototypal inheritance. So again, prototypal inheritance means that all objects that are linked to a certain prototype object can use the methods and properties that are defined on that prototype. So basically, objects inherit methods and properties from the prototype, which is the reason why this mechanism is called prototypal inheritance. Just note that this inheritance is actually different from the inheritance that we talked about in the last lecture. So that was one class inheriting from another class. But in this case, it's basically an instance inheriting from a class. So that's very different, and so keep that in mind. Or maybe in your notes. All right? Now we can also say that objects delegate behavior to the linked prototype object. And behavior is just another term for methods here. So besides prototypal inheritance, we also call this mechanism delegation. And that's also the reason why this arrow is pointing upwards, because technically objects delegate their behavior to the prototype. On the other hand, in classical OOP with classes, the behavior, so the methods, are actually copied from the class to the objects. And so that is completely different. Now, I don't want you to stress out about the exact terminology here, okay? So I know that this is a lot of new stuff to take in, so a lot of new words and new concepts. But this is just to paint a very clear picture and to give you the complete overview. What matters to me is that you understand how this prototypal inheritance actually works. Because when we actually start using this in practice in the next lecture, it won't really matter if it's called inheritance or delegation, as long as it just works as intended, right? But since you came to this course to learn how things actually work in JavaScript, I'm giving you all that information here. Even though for now it looks a little bit too much, but I'm sure you will find it useful eventually. So actually, we will come back to this diagram and fill it with some more detail after we have actually implemented prototypes in JavaScript. So after you have actually see how they work in practice. And by then, I'm sure that all this will make 100% sense to you. But anyway, we have actually already seen this mechanism in action many times before, but without knowing that it was happening. For example, each time that we use an array method like map, we are able to use that method because of prototypal inheritance. So when you go to MDN to check the documentation for any array method, what you will see there is that it's actually called array.prototype.map. But why is that relevant? So what does this mean? Well, array.prototype is the prototype object of all the arrays that we create in JavaScript. So just like this example array called num here. Now this prototype object contains all the array methods, including map. So this is where they are actually defined. So since array.prototype is the prototype of the num array, it means that num is linked to that prototype, and therefore it has access to all the methods that are defined on the array.prototype object, just like the map method. So in a sense, our array inherits the map method. Or again, we can also say that the array delegated the behavior of mapping to its prototype. So you can choose whatever makes more sense in your mind. But what matters is that the map method is actually not defined on the num array itself, but on its prototype. And of course, we're going to check out this behavior also in our code in practice. Okay? Now, right now, you might have a ton of questions in your head. Like, how do we actually create prototypes? And how do we link objects to prototypes? And how can we create new objects without having classes from which we can instantiate objects? So, in summary, the question is, how do we implement object-oriented programming in JavaScript in practice? Well, in JavaScript, there are actually 3 different ways of doing all this. The constructor function technique, ES6 classes, and also the object.create function. So first, constructor functions are a way of creating objects programmatically using a function, which will also set the new object's prototype. And this is actually how built-in objects like arrays or maps or sets are implemented. Also, this is how OOP has been done in JavaScript, basically since the beginning. Next, the ES6 release introduced classes into JavaScript. And so now, ES6 classes are actually the more modern way of doing OOP in JavaScript. However, keep in mind that these are actually not the kind of classes that we talked about in the last lecture and in the last slide. They are, instead, just so-called synthetic sugar over constructor functions. So this means that ES6 classes are basically just a layer of abstraction over constructor functions. So it's really just a nicer syntax that makes it easier for newcomers to do OOP in JavaScript. But behind the scenes, ES6 classes are actually implemented with constructor functions. And so they also use prototypal inheritance, just like we learned in the last slide. Finally, there's also the object.create function, which is basically the easiest and most straightforward way of linking an object to a prototype object. However, it's not as used as the other two methods, as we will see over the next couple of lectures. Now, to finish, one important thing to keep in mind is that the 4 principles of object-oriented programming that we learned in the last lecture, so that's abstraction, encapsulation, inheritance, and polymorphism, are still valid and important with prototypal inheritance. And throughout this section, we will of course learn how to use and implement these principles. Alright, and with all that being said, let's now finally put OOP into practice and get a bit more technical. Let's finally implement object-oriented programming now, and starting with constructor functions. And as always, I already have the starter files open here in my VS Code editor. So please go ahead and do the same now, and we can actually already also open up a new terminal and start our live server. So we can close that, open up the console here, increase it a little bit, and now we're all set up and ready to go. So we actually kind of used object-oriented programming before, but in a very limited way, because we had no way of programmatically creating objects. And so all we did was to use some simple object literals, for example, in the Bankist app, right? But now that all changes with constructor functions. So we can use constructor functions to build an object using a function. Now, a constructor function is actually a completely normal function. The only difference between a regular function and a function that we call constructor function is that we call a constructor function with the new operator. But enough talk, let's now actually create a constructor function for a person. So that's person, and in OOP there is this convention that constructor functions always start with a capital letter. And so we should always follow that convention too. And in fact, other built-in constructors like array or map follow that convention as well. Now here I'm using a function expression, but of course a function declaration will also work. Now an arrow function will actually not work as a function constructor, and that's because it doesn't have its own this keyword, and we need that. Okay, so only function declarations and function expressions. Now remember that this function is basically going to produce an object, and in this case for a person. So we want the person to have a name, or let's say a first name, and a birth year. And so we specify these two parameters for that here in our constructor function, so that we can then pass in the name and the birth year. And now let's actually call this function. And so, as I said previously, the only difference between a regular function and a constructor function is that we call the constructor using the new keyword. So we write new, then person, and then let's pass in Jonas and 1991, let's say. So this new operator here is actually a very special operator, because what it does is to call this function here, so this person function, but it does a whole lot more than just that. So let's see what exactly happens when we call a function with the new operator like this. So behind the scenes, there happen 4 steps. And let me actually write them here because this is very important. So first, a new empty object is created. So an empty object is created. Then afterwards, the function is called, and in this function call, the this keyword will be set to this newly created object. All right, so let's write that here. So the this keyword is this new empty object. So basically, in the execution context of the person function, the this keyword will point to this new object here that was created in step number 1. And remember, all of this happens only because we are calling the function using the new operator here. So step number 3 is that this newly created object is linked to a prototype. So linked to prototype, but more about this in the next video. For now, we just care about creating the object itself. Finally, the last step is that the object that was created in the beginning is then automatically returned from the constructor function. So the function automatically returns that empty object from the beginning. But actually, at this point, the object no longer needs to be empty. And this is actually the trick of making the constructor function work. So let's go here now and log to the console the this keyword. And so we already know that it should be this empty object that was just created here in step number 1, right? Because the this keyword inside this function will be exactly that empty object. And again, that's because we are calling it with the new keyword. So let's see. And indeed, we get this empty object. And the browser console is actually already telling us that it's basically here of the type person. All right. And so this is just the name of the constructor function. All right. And now let's use this knowledge to our advantage, because we already know that in the end of this function, the this keyword will basically be returned. And so whatever we add to that empty object will then be returned from the function. And that returned object is going to be the object that we are trying to build here actually. So all we need to do is to now take that first name parameter, so the value that we receive, and then create a property on the this keyword with the same name and then set it to that value. And then the same with the birth year equal to birth year. And so now let's store the result here in some variable, and that's actually it. So let's see what Jonas is going to look like. Now, and we have to log it to the console here if we want to take a look at it. And indeed, here it is. Here is the person object with the first name Jonas and the birth year that we passed here into the constructor function. So let's quickly recap what just happened here. So again, we're calling this constructor function with the new keyword or the new operator. And so therefore, a new empty object is created right away. Then the function is called, and in here, the this keyword is that empty object. And then in the function, we start to set properties to that object. And we give them the exact same name as the parameters that we're passing in here. And of course, they could have any other name, so it doesn't have to be the same name as our arguments. So it doesn't have to be the same name as our parameters, but this is kind of a convention. So if we pass in first name, then we should also create a property called first name. So then here, by the end of the function, or this keyword now has these two new properties. And then here in step number 4, that object that was created in the beginning is then automatically returned from the function. And so at this point, that is the object with these two properties. And so that's going to be the result of this function call. And so it will then be stored in Jonas. And then that's what we get here. Great. So I hope that made sense. And so now, of course, we can use this constructor function to create as many different objects as we want. So let's say we want to create Matilda, new person, Matilda, and then let's say 2017. And let's just do another one. Why not? Let's call it Jack, new person, just so you see that we can create as many objects now based on this constructor function. And so this is a bit like the analogy from before, where this constructor function is now the blueprint for a house, and then each of these objects that we create through that function, so through that blueprint, will be the actual house in the real world. So in this case, the actual objects with actual data in them. So Matilda and Jack. And so of course, now each of them is its own new object that we created programmatically using a function constructor. Now remember from one of the previous lectures that in classical object-oriented programming, an object created from a class is called an instance, right? Now we didn't technically create a class here because, as we discussed before, JavaScript doesn't really have classes in the sense of traditional OOP. However, we did create an object from a constructor function. And actually 3 objects, right? And constructor functions have been used since the beginning of JavaScript to kind of simulate classes. And so therefore, we can still say that Jonas here is an instance of person. And the same goes for Matilda and for Jack here. And in fact, there is even an operator that we can use to test for that. So that works like this. So Jonas is an instance of, and then person. And so this will then return either true or false. Now, if we created something else here, let's say J, just like this, then if we do this, this should of course be false, right? Because of course we didn't create this variable here, so this object, using any constructor function. All right. And since we're talking about instances here, we can also say that these properties here will be the instance properties. Let's write that here. And that's because the properties first name and birth year will be available on all the instances that are created through this constructor function. So that's for properties. But now what about methods? So what if we wanted to add a method to our objects? Well, just like we added properties, we can of course also add methods. So let's again use our old friend calc_age here. And so here we are going to create a function and assign it to this property. And so this will then basically become a method, right? And this here should simply log to the console 2037, which is the year we've always been using, and then minus this dot birth year. And so this method is exactly the same that we've been using all the time, right? So this would work just fine here, but this is actually a really bad practice. So you should never do this. You should never create a method inside of a constructor function. That's because imagine we were going to create 100 or thousands or even tens of thousands of person objects using this constructor function. Then what would happen is that each of these objects would carry around this function here. So if we had 1,000 objects, we would essentially create 1,000 copies of this function. And so that would be terrible for the performance of our code. Again, don't do this. But instead, to solve this problem, we are going to use prototypes and prototypal inheritance, just like we discussed in the last video. All right, great. So this is the basics of constructor functions. Just note that function constructors are not really a feature of the JavaScript language. Instead, they are simply a pattern that has been developed by other developers, and now everyone simply uses this. And this now includes you as a new developer. So the real magic really here is this new operator. And so the most important thing to understand from this video is really these 4 steps. So make sure that you understand them, and then in the next video, we will work with prototypes and finally see the magic of prototypal inheritance in action. Now it's time to finally start using prototypes. And after this, you will feel like a real pro developer, believe me. And we're going to continue with the example from the previous video. Okay, but now we're going to talk about prototypes. So actually, we talked about prototypes, prototypal inheritance, and delegation earlier already. But how does all of that actually work? Well, it can be summarized like this. So first, each and every function in JavaScript automatically has a property called prototype. And that includes, of course, constructor functions. Now, every object that's created by a certain constructor function will get access to all the methods and properties that we define on the constructor's prototype property. So just to visualize, in our case, this would be person dot prototype. So the prototype property of the constructor function. So again, as I was just saying, all the objects that are created through this constructor function here will inherit, so they will get access to all the methods and properties that are defined on this prototype property. And so let's now actually add a method to this prototype property. And so this is actually an object, and so we can now say calc age. And then we can simply set it to this same function here. So equal, and that's it. Now we get some error here, and that's because I misspelled prototype. So that's type right here. And let's actually take a look at this prototype property just for curiosity. So that's not comma, of course, it's the dot. And so here is that prototype property. And so you see that right now we already have the calcH method in there. So before it was kind of an empty object. So never mind these two here. So basically it was empty before, but now there is the calcH method already in here. So this one that we just defined down here. All right, and once again, remember how I said that each object created by this constructor function will now get access to all the methods of this prototype property. And so, of course, also to calcH. And so we should be able to do this. So Jonas, which is this object here, which was, of course, created by this constructor function. And so calcH. And let's see. And indeed, we get the correct age here. So it worked. Great. That's amazing. So we can now use this method here on the Jonas object, even though it is not really on the object itself, right? So if we check out Jonas here, then you see that it contains, of course, the birth year and the first name, but it does not contain the calc_h method. But still, we have access to it because of prototypal inheritance. Okay? And of course, the same is going to work for Matilda here, and of course, also for the Jack object. Beautiful. So that effectively solves this problem that we had before when we added the calc_h method directly to each of the objects. Remember that? So here we would have created a copy of this method here and attached it to every single object. And so that's why we don't do this. Instead, what we do is this, because now there exists only one copy of this function. So only one of them exists, but then all of the objects that are created using this constructor function can basically reuse this function on themselves. And so the this keyword, of course, in each of them is, as always, set to the object that is calling the method. And so here that's Jonas, and here that's going to be Matilda. So just like we learned previously, the this keyword is set to the object that is calling the method. All right, so in a nutshell, this is how we implement very basic prototypal inheritance in JavaScript in practice. So we just observed that the Jonas and the Matilda objects are kind of somehow connected to the person, right? That's why they can have access to these methods, or in this case, to just this method that is located inside the prototype property of person. But how and why does this actually work? Well, it works because any object always has access to the methods and properties from its prototype. And the prototype of Jonas and Matilda is person.prototype. And we can actually confirm that because each object has a special property called __proto. So like this, __proto, and then again __. So this looks a bit weird, but this is just kind of how it works. So let's take a look. And so this is the prototype of Jonas. It's not the prototype property, but it is simply the prototype. Okay, and so here again, we see the calc_h function, and that's why Jonas is able to use this. So the prototype of the Jonas object is essentially the prototype property of the constructor function. So let's quickly see that as well. So we can check that. So person.prototype. And so this should now be true. And indeed, it is. All right. But what I just said sounded incredibly confusing, didn't it? So shouldn't person.prototype be the prototype of person? I mean, should this prototype property here not be the prototype of person? Well, actually, no. So this is the confusing part. So person.prototype here is actually not the prototype of person, but instead it is what's going to be used as the prototype of all the objects that are created with the person constructor function. So that's a subtle but important difference that you need to keep in mind. And in fact, what I just said is confirmed by this comparison that we just did here. So we just saw that Jonas's prototype, which is this, is the prototype property of the person constructor function. And there are actually other built-in methods that we can use to prove this. So on any object, for example, object.prototype, we can test if this is a prototype of another object. So we can call is prototype. So is prototype like this of, and then Jonas. And so this should also become true. And indeed, it is. So this confirms one more time that person.prototype is indeed the prototype of Jonas. And the same for Matilda, of course, as well. But person.prototype is not the prototype of person. So you see, it is false here. So this very common confusion comes from bad naming of this property. So the fact that it's called prototype kind of implies that this is the prototype of person. But as we just learned, it is actually not. Probably shouldn't be called prototype, but instead something like prototype of linked objects or something like this. So if this makes it easier, you can think of the prototype property as prototype of linked objects property. Even though, of course, it's not called like this, but this would be a more honest name. So take some time to really understand what the prototype of what object actually is here. Now, anyway, where does this property here on the Jonas object actually come from? Well, remember the new operator that we talked about before? Well, it contains this step number 3, which links the empty new object to the prototype. And so basically, it is this step number 3 which will create this proto property. So it creates this proto property and it sets its value to the prototype property of the function that is being called. And so that's exactly what is written here, right? So again, it sets the proto property on the object to the prototype property of the constructor function. And so this is how JavaScript knows internally that the Jonas object is connected to person.prototype. And in fact, when we check out the Jonas object here, we can indeed also see that property in here. So it's also right here. And if we open that up, then you see exactly person.prototype, which contains this calc_h function. All right. So I'm spending a lot of time here for you to really understand what this proto property here is and what the prototype of the constructor is and how they are all linked, because this is one of the most important things and also one of the most difficult things to understand in JavaScript. But I hope that it's becoming increasingly clear, and there will also be a couple of diagrams in the next video that will basically bring all this knowledge together in an easier to understand way. So by now you're probably sick of hearing the word prototype, but I just wanted to quickly show you that we can also set properties on the prototype. And so not just methods. So let's say person.prototype.species. And so this is something that all of the objects here will have in common. And so that's Homo sapiens. All right. And so if we now take a look at Jonas and at Matilda also, then we should see this property, so the species, on both of them. And actually not directly here, but indeed they will be here in this prototype. And so we will be able to do Jonas.species and Matilda.species. And both of these objects will then inherit, so they will get access to this property from the prototype. So you see, in both cases, we indeed get Homo sapiens. Now, however, since when we take a look at these objects, well, as we just saw, this property is not really directly in the object. So it's not its own property. So own properties are only the ones that are declared directly on the object itself. So not including the inherited properties. And actually in JavaScript, there is a way of checking for that. So we can do Jonas has own property. So that's with a capital P here. And so let's first check for first name. And indeed, this object does have its own property with this name. But now if we try species, then that is going to be false. And again, that's because this property is not really inside of the Jonas object. It simply has access to it because of its prototype. So because it's in the prototype property of person. So right here. Right? And sometimes this method here can be quite helpful in certain situations. All right. And that is probably enough for one lecture. And as I just mentioned earlier, in the next video, I'm going to show you a nice diagram of all of this. So stay tuned for that one. Let's now consolidate the knowledge that we got over the last two videos in a nice diagram that brings everything together that we know so far. And everything starts with the person constructor function that we've been developing. Now, this constructor function has a prototype property, which is an object, and inside that object, we defined the calc_age method. And person.prototype itself actually also has a reference back to person, which is the constructor property. So essentially, person.prototype.constructor is going to point back to person itself. Now remember, person.prototype is actually not the prototype of person, but of all the objects that are created through the person function. And speaking of the created objects, let's now actually analyze how an object is created using the new operator and the constructor function. So when we call a function, any function with the new operator, the first thing that is going to happen is that a new empty object is created instantly. Then the this keyword in the function call is set to the newly created object. So inside the function's execution context, this is now the new empty object. And that's why in the function's code, we set the name and birth year properties on the this keyword, because doing so will ultimately set them on the new object. So next comes the magical step. So now the new object is linked to the constructor function's prototype property. So in this case, person.prototype. And this happens internally by adding the __proto property to the new object. So person.prototype is now the new object's prototype, which is denoted in the __proto property of Jonas. So again, _proto always points to an object's prototype. And that is true for all objects in JavaScript. Great. And finally, the new object is automatically returned from the function unless we explicitly return something else. But in a constructor function like person, we usually never do that. Okay, and with this, the result of the new operator and the person constructor function is a new object that we just created programmatically, and that is now stored in the Jonas variable. And this whole process that I just explained is how it works with function constructors and also with ES6 classes, but not with the object.create syntax that we're going to use later. So just keep this in mind once we reach the object.create lectures. But anyway, why does this work this way? And why is this technique so powerful and useful? And to answer that, let's move on to the next line of code. So here we are attempting to call the calc_age function on the Jonas object. However, JavaScript can actually not find the calc_age function directly in the Jonas object, right? It is simply not there. And we already observed this behavior in the last lecture. Remember that? So what happens now in this situation? Well, if a property or a method cannot be found in a certain object, JavaScript will look into its prototype. And there it is. So there is the calc_h function that we were looking for. And so JavaScript will simply use this one. That's how the calc_h function can run correctly and return a result. And the behavior that we just described is what we already called prototypal inheritance or delegation. So the Jonas object inherited the calc_h method from its prototype. Or in other words, it delegated the calc_h functionality to its prototype. Now the beauty of this is that we can create as many person objects as we like, and all of them will then inherit this method. So we can call this calc_h method on all the person objects without the method being directly attached to all the objects themselves. And this is essential for code performance. Just imagine that we had 1,000 objects in the code, and if all of them would have to carry the calc_h function around, then that would certainly impact performance. So instead, they can all simply use the calc_h function from their common prototype. Okay? So that makes sense, right? Now, the fact that Jonas is connected to a prototype and the ability of looking up methods and properties in a prototype is what we call the prototype chain. So the Jonas object and its prototype basically form a prototype chain. But actually, the prototype chain does not end here. So let's understand the prototype chain a bit better by zooming out and looking at the whole picture. So here is the diagram that we already had with the person function constructor and its prototype property, and the Jonas object linked to its prototype via the _proto property. So nothing new yet. But now let's remember that person.prototype itself is also an object. And all objects in JavaScript have a prototype, right? Therefore, person.prototype itself must also have a prototype. And the prototype of person.prototype is object.prototype. Why is that? Well, person.prototype is just a simple object, which means that it has been built by the built-in object constructor function. And this is actually the function that is called behind the scenes whenever we create an object literal. So just an object simply with curly braces. So essentially the curly braces are just like a shortcut to writing new object. Okay? But anyway, what matters here is that person.prototype itself needs to have a prototype. And since it has been created by the object constructor function, its prototype is going to be object.prototype. It's the same logic as with the Jonas object. So since Jonas has been built by person, person.prototype is the prototype of Jonas. Alright? Now this entire series of links between the objects is what is called the prototype chain. And object.prototype is usually the top of the prototype chain, which means that its prototype is null. So its _proto property will simply point to null, which then marks the end of the prototype chain. So in a certain way, the prototype chain is very similar to the scope chain, but with prototypes. So in the scope chain, whenever JavaScript can find a certain variable in a certain scope, it looks up into the next scope in the scope chain and tries to find the variable there. On the other hand, in the prototype chain, whenever JavaScript can find a certain property or method in a certain object, it's gonna look up into the next prototype in the prototype chain and see if it can find it there. Okay? So again, the prototype chain is pretty similar to the scope chain, But instead of working with scopes, it works with properties and methods in objects. All right? And now let's actually see another example of a method lookup. To do that, we call the hasOwnProperty method on the Jonas object. So just like in the previous slide, JavaScript is going to start by trying to find the called method on the object itself. But of course, it can't find the hasOwnProperty method on Jonas. So according to how the prototype chain works, it will then look into its prototype, which is person.prototype. Now, we didn't define any hasOwnProperty method there either, and so JavaScript is not going to find it there. And so, therefore, it will move up even further in the prototype chain and now look into object.prototype. And object.prototype does actually contain a bunch of built-in methods, and hasOwnProperty is one of them. Great! So JavaScript can then take this one and run it on the Jonas object as if hasOwnProperty had been defined directly on Jonas. And remember, the method has not been copied to the Jonas object. Instead, it simply inherited the method from object.prototype through the prototype chain. Okay, and that's actually it. That's all I have to tell you at this point. So this is, in a nutshell, the magic of prototypes and the prototype chain. And this will actually become even more interesting and useful once we add inheritance between two different kinds of objects, or two different classes, so to say. For example, having a student class inherit from a person class, just like we learned in one of the 4 pillars of OOP. Remember? So there is a lot of exciting stuff ahead, and so let's move on. Let's now check out prototypal inheritance and the prototype chain on built-in objects such as arrays. But actually, let's start this lecture by inspecting some of the stuff that we just talked about in the last lecture. And we will keep using this person example that we have been building. So let's start by taking a look at Jonas.__proto. And we already know that this is the prototype of Jonas, which is exactly the prototype property of person. And so therefore it is this object which contains the calc_h method that we defined earlier, so up here, and also this property, so this species property. But now let's actually move up in the prototype chain and essentially take a look at the prototype of Jonas's prototype. And do you remember from the last video what that's gonna be? Well, let's see. And it is indeed the prototype property of object. So that's why you can see that constructor is the object here. And then right away, we see this method that we actually already studied in the last video. So this hasOwnProperty. And so this is the reason why we can do this. So why we can call hasOwnProperty on Jonas, like we did here in one of the earlier videos. So again, we learned in the last lecture that this works because of the prototype chain. And in particular, because this method here is in this prototype of Jonas's prototype. And so, yeah, that's this object that we are inspecting right now. All right. Okay, but let's take this one step further and check out the prototype of the prototype of the prototype. And do you remember what this one is? That's right, it is null. And so that's because object.prototype is usually the top of the scope chain. So this one here, right? So this one is going to be object.prototype. And so that's the top of the prototype chain. Okay. Now we can also take a look at that strange constructor property that we also saw earlier. So remember, person.prototype itself has a constructor property, which, as we said, will point back to the person itself. So constructor like this. And so here we actually get the function itself. Now, if we want to inspect that function, here we need to use console.dir. And so here indeed, we see that the constructor property points back at person. So that's this. Now, to make things a bit more complicated even, let's now take a look at the prototype of a function. So any function, of course, is also an object, and so therefore it also has a prototype. But maybe this is a bit too confusing, so let's just leave it here. So I will first show you the prototype of arrays, and maybe then we can move a bit further to functions. So actually, let's do that now. So let's create an array, just like with any random numbers. So the values here don't matter at all. All I'm interested in is now to take a look at the property. So the prototype of the array. So let's see. And here it is. So this is the prototype of array. And you see that here we have all these methods that we already know. So we have fill, we have filter, find index, and all of these methods that we studied in one of the earlier sections. And so this is the reason why all the arrays get access to all of these methods. So each array does of course not contain all of these methods, but instead each array will inherit these methods from its prototype. All right. And we can also check out that this prototype has got to be exactly array, which is the constructor function, dot prototype. So one more time, the prototype property of the constructor is going to be the prototype of all the objects created by that constructor. And so let's see, and it is true indeed. And just like in objects, using this shorthand basically is the same as using new array. And so therefore, whenever we create an array like this, it is indeed created by the array constructor. And so that's why all of this works behind the scenes. But of course, this is not yet the end of the prototype chain as we saw in the last video. So let's see. And so now we are back to having object.prototype. You see, so this again now has own property, and then all of these methods here that are available for objects. And one more time, that is simply because the prototype itself here is an object. And so any object has access to all of these methods. All right. Now we would be able to see the exact same thing also directly in the console. So if I check out the array here and open it, then here in the bottom, you will see that we have the prototype property right here. So if we click that, then here one more time, we get all these array methods that we already know. Okay. And if we check the documentation on MDN, for example, for filter, then you see that actually the name of the method is array.prototype.filter. And that is because this filter method does, of course, live in the prototype property of the array constructor. So, one more time, you can see that the prototypal inheritance is really a mechanism for reusing code. So all of these built-in methods here have to exist only once somewhere in the JavaScript engine, and then all the arrays in our code get access to the functions through the prototype chain and prototypal inheritance. Great. So let's actually take this one step further. So we know at this point that any array inherits all their methods from its prototype. And therefore, we can use that knowledge to extend the functionality of arrays even further. So all we would have to do is to say array.prototype, and then here we can add any new method to this prototype, and all the arrays will then inherit it. So let's say that we wanted to create a method which returns all the unique elements of an array. So let's add a method called unique. So we set the unique property to a function, and then to get the unique values of an array, all we have to do is to create a new set and pass the array in there. And the this keyword is going to be the array on which this method will be called. And so now we just need to put this into an array and spread it like this, as we have already done multiple times before. And so we can now use that. So array dot unique, and this should now return an array with only the unique values. Well, we don't have a lot of duplicates here. Let's add another 6 here and maybe another 9. And so let's see what happens. And indeed, that worked. Beautiful. So just to recap, we added a new method to the prototype property of the array constructor. And so therefore, now all arrays will inherit this method. And so we can then call that method on any array that we want. However, what we just did here, so extending the prototype of a built-in object, is generally not a good idea. I mean, if you're working just on a small project on your own, then I guess you could do this. But really, don't get in the habit of doing this for multiple reasons. The first reason is that the next version of JavaScript might add a method with the same name that we are adding, for example this one here, but it might work in a different way. And so your code will then use that new method, which remember works differently, and then that will probably break your code. And the second reason why you shouldn't do this is because when you work on a team of developers, then this is really going to be a bad idea. Because if multiple developers implement the same method with a different name, then that's just going to create so many bugs that it's just not worth doing this. So it's just a nice and fun experiment, but in practice, you should probably not do it. Now, for a little bit of fun, to finish this video, let's take a look at some more built-in objects here in the console. So for example, we can select this DOM element here. And so let's do that, this h1. So that's document.querySelector h1. And we already know that all the DOM elements are behind the scenes objects. And so let's take a look at this object. Well, that doesn't really work. So that just gives us the object. So let's try console.dir on this h1. And so now we get the actual object. So here we have all this different stuff and all these properties and methods that we already worked with. But what I'm interested in here is the prototype. And you see that the prototype is an HTML heading element. All right, and so that itself will contain a lot of different stuff one more time. So let's scroll all the way down. And so this is now an HTML element. And do you remember these names here from somewhere? Well, these are exactly the types of objects that we talked about in one of the first lectures in the DOM section. Remember that? So we had this big diagram with all these different types of elements. And so now here we can actually inspect them. And so behind the scenes, these different elements are really different like constructor functions. So if we go down here, we should now see element. And indeed, here it is. And so again, you can recall that diagram that we inspected there, and then you will remember that HTML element was a child element of element, and element itself was a child of node, right? And so therefore the prototype of element is gonna be node. So if we scroll all the way down here, then you see indeed node, and now this one is event target. And so you see this is a huge prototype chain. And only now we are at the end. And so the end is then object. And that's it. So this prototype chain has easily 6 or 7 levels. And so you see that it can go really deep. So if you want to go and check this out by yourself, then that would probably be a really nice exercise. And finally, let's just also console.dir some random function. So the function doesn't matter. I just want to be able to look at the function. Okay. And so as I mentioned a bit earlier in this video, the function itself is also an object. And so therefore, it also has a prototype. And in this case, the prototype will then contain the methods that we have used previously on functions. So that's apply, bind, and call. Remember? And so once again, this is the reason why we can actually call methods on functions. It's because they are objects, and objects have prototypes. And in this case, this function prototype. So you can spend a lot more time if you're really interested in exploring all of this. But once you think you have a good understanding of all the previous lectures, then you can move on to the next video, which is going to be the first coding challenge of this section. Welcome back to your first coding challenge of this section. So now it's time to finally put everything that you learned in this section so far into practice. So in this section, I want you to use a constructor function in order to implement a very simple car. All right. So for this purpose, a car has just a make and a speed property. And the speed is simply the current speed of the car measured in kilometers per hour. Then I want you to implement an accelerate method that will increase the car's speed by 10, and it should also log the new speed to the console. Then another method called brake, which will then decrease the speed, but only by 5. All right. And finally, I want you to use this test data down here to implement these 2 cars. So basically to create 2 car objects and then experiment with calling the 2 methods that we just created on each of the objects. And of course, you should use all the knowledge from the previous lectures to doing this. So I hope that this is a fun challenge that's not too hard. So take all the time that you need, and I see you back here when you're ready with my solution. All right. So hopefully you did that successfully. So let's get started here. So we create the constructor function for car, and one more time with a capital C. And then we want each car object to have a make and a speed. And so that's the arguments that we're going to pass into this function. And then just as before, on the this property, we will set the make to the make that we receive and the speed to the speed that we receive as well. And so this is basically always going to work the same way. So as I mentioned, this is a pattern that developers came up with. And so now we just simply follow this like a recipe. All right. And with this, we can actually already create our 2 cars. So let's say the BMW is a new car. And so remember, this new operator here is what's going to enable all of this to work. And so here the make is of course BMW, and the speed is 120 kilometers per hour, which for my American friends is 75 miles per hour, I believe. So the next one is going to be the Mercedes. So that's new car, and at speed 95 kilometers per hour. Okay, so let's just take a look. And so yeah, that appears to be working just fine. And so now let's implement our two methods here. So accelerate and brake. And of course, we are not going to add the method right here. So we will not do this dot accelerate, because as we just learned before, that would be terrible for performance, especially if we had many car objects. So instead, we will of course make use of prototypal inheritance. So we take the prototype property of car, and to that we add the accelerate property. Accelerate, that's correct. And we make it a method by passing in a function, or actually by specifying a function here. So once again, we can use the this keyword in here, because that is simply going to be the object on which the method will be called. And so that object will have the speed property. And so here we can then increase that by 10. And then we can also log that to the console. And we can even make use, of course, of the make. So this one wasn't specified in the text, but we can log a nice string like this is going at this dot speed, and then kilometers per hour. But again, this part you wouldn't have to implement like this. And now let's just take this here for the brake, because it's going to be pretty similar. So brake, and all we do then is to decrease the speed by 5. All right, and now let's just call this on the BMW a couple of times. So BMW dot accelerate, and let's do that 3 times. And so after 3 times, the BMW is going at 150 kilometers per hour. So apparently that works just fine. Let's just add a brake here in the middle. And so now we reduce the speed a little bit and then back up to 145. Okay, and that's actually it. That's all we had to do in this challenge. And maybe with this example, you can start to see the advantages of object-oriented programming in action. So all the advantages that we talked about right in the first lecture of this section. And essentially the part where we learned that in object-oriented programming, we pack both the functionality and the data into objects. And so that's exactly what we have here. So each of these objects, so BMW and Mercedes, contains the state of the car, so the current speed and the make, and it also contains the functionality to manipulate its own data. So the accelerate and brake methods in this case are able to manipulate the speed, right? And at the same time, these two methods also form the public interface of this object, right? So right now the rest of our code can interact with these objects by calling the brake and the accelerate methods. Now in this case, of course, this is just a very small and isolated example, so it can still be hard to see the advantages of this, but maybe you can take a minute or two and compare this style of coding with the code that we have written up until this point in the course. All right, so at some point you will see that this is really a completely different way of thinking about our code. But anyway, that's it for this challenge. In the next video, we are going to talk about ES6 classes. So I hope to see you there soon.